doing that now for homework?
Just copy that. Yeah.
Oh,
Yeah.
okay, you took one for it. All right, let's finish this question off then. So, using Pythagoras' theorem, we set it out like this. What was the change of this question compared to the other? It was rotated, isn't it? So this is a common thing they do. The other questions we've done, you see the triangles are kind of one way, quite how you'd expect to see it. And then they do try and like test your knowledge by changing the triangle rows. Because quite often people think, oh, well, this bottom side is always going to be one of the short ones. It's going to be the A or the B. And it's not the case. So I've labelled that side C. Why is that the one that should be C?
Because it's the biggest.
The longest side. Yeah. So the other two, A and B, they give you the two smaller squares. Remember, Pythagoras' theorem was two smaller squares add together to make the larger square, which not very well done on mine, but we did that at the beginning. So right, so I drew a square, two small squares, and then I said if you drew a bigger square, those two added together would give you the same area. So that's Pythagoras' theorem, and we are now applying it. And we did it to some basic ones. So we're finishing this one off. So the area of one of the small squares, 3.7 squares. The area of the other small square is the unknown one. The area of the large one is what we know. So, to finish this one off, can you do the calculations for me? So, we do have 36.69. I don't have 3.7 squared.
Okay. There's 13.6.
That's 13.69. And then plus, well, b squared will be this one. This is the one we don't know. And that will equal the 39.69, the one we did. So 3.7 squared plus b squared was equal to the 6.3 squared. And how do we therefore figure out the one we want to know?
Subtract 13.
Exactly. So we do 39.69, subtract the 13.69, and that will leave me with what b squared. So b squared is equal to 26. Okay. And then to finish off, if b squared is 26, we actually need to know the length of the side of the square. So we need to do b, which is that, is equal to the square root of 26, which is
5.0.
So b is 5.0. Is that it, exactly that, or are there any other numbers? Yeah.
The bottom, that's 26, not 2.6, right?
That is 26, yeah.
It's 5.099.
So 5.099. Okay? That means if we have to round it to three significant figures, it would be 5.09. But this 9 would actually round us up. So it will become 5. Well, that rounds that up, which would then go on to the next one. So it would actually be 5.1 but because it has to be three significant figures, we do actually have to put a 0 there.
Wait, I have a question.
Yes.
So if I put 5.09, would the whole question be wrong?
Yeah.
What I
Do
use?
you remember last time you asked that and I said, if you are getting rounding mistakes, then they normally have like 1 mark they would take off over the entire thing. Yeah, and then they don't penalise it again. Okay. But 5.09 in your answer is actually quite a difference. I would then say, just check that answer makes sense. As always, put it up here, 5.10. Does that number make sense in that diagram?
Yeah.
Why?
Because it's number.
Yeah, it's roughly in the right ballpark, same as these, but it's definitely not longer than that one. This one has to be the longest side, this is the biggest area. Okay. So it makes sense, put it in the diagram just as to do a fine check. I mean, obviously there's no extra marks for doing that, but it can gain some marks if you realise you've made a mistake because the number is way out, right? It's a check. Okay. My hope for this lesson was to start going on to questions that involve a little bit more interpretation of the problem. Okay. So we have a rectangle that has been cut. Right. Now Pythagoras' theorem is to do with right angle triangles. Can you see a right angle triangle in that? Two, yeah, 2 put together. You have to, in this question, calculate the length of side CD. So for me, I'm going to say this is the side that I want to work out. Right? Now, if we're going for a triangle, I'm going to identify that triangle, and I don't need anything else. So I've identified the triangle. So I'm going to say, on our notes, let's put identify the right angled triangle to be used. So that's what I've just done. And this is the side that I wanted to know. And then it was labeling the sides. So we want to know which one's A, which one's B, which one's C. What do you think?
C will be 17.
C is going to be 17, yeah. And then the A and the B, doesn't matter. We're going to put A there and B there. And like I said, at the moment I am still small, medium, bigger. So we've got A squared plus B squared C squared. You guys carry on with that?
Yeah.
Got any questions, Luke?
Yep.
No, a question or no question? Are you okay?
Oh, no, I was wondering, this word on here, so I was worried I was on the wrong one.
No, I've just drawn.
Oh.
So what I did, just as a review thing, like just so we get used to what's actually happening. So look, a lot of problems with Pythagoras' theorem comes when people say, because it's A squared plus B squared is C squared. The problem comes when people just start adding A and B together and making C's. Yeah?
Yeah.
So I tried to make it very obvious that it's not the sides that we're adding together, it's the areas of the squares, you know, like that you had on the front sheet. Right? So just to keep that forefront in my mind, at the moment, I am drawing the squares. Right? Eventually, you might choose not to and just to write a squared plus b squared with c squared, you carry on. But I thought it's quite a nice visual check to say it's always about the squares and not about the sides. You don't add the sides. Right, I'll let you guys. That diagonal means straight across a shape from one corner. There is a better name for corner. Okay. Call it vertex. To another. So lots of shapes can have diagonals. They don't have to be going diagonal. They could be going vertically up or across. So just as an example, look, if I were to draw this shape, which is a kite, okay, a diagonal would be straight down the middle. That would be one diagonal. This would be another diagonal. So the fact that this is a diagonal and it is diagonal is coincidental in this case. Alright. Do you all know how the size of your TV screen is worked out? So if you've got a 50-inch TV screen, where's that measurement taken? The diagonal. Yeah? Yeah. So you see some kind of funny comments online of things where people look silly because they get their 50-inch TV home and they go, but it's only 42 inches. Like, yeah, because you measured along the bottom and it's not how it's done, you know. So we, in this case, we're introduced to that. Is it pretty much the same as the last question?
Yeah.
Okay. So we are basically being asked to work out the length of the diagram. Now, if that diagram wasn't there, you would have to draw your own and understand what that word diagram meant. That's why we did this.
Yes, it does.
Yes.
Would it help the definition? Yeah. Or opposites?
For what?
If you come down on the definition. Yeah, the definition, guys,
Yeah.
you wrote it. Can you show it to us again?
Straight across the shape from one corner to another.
The opposite.
No.
It wouldn't work.
That's not true. Because if I have a hexagon, for instance, that is a diagonal there. This is a diagonal, okay, but that is also a diagonal. Because it goes across the shape to another corner. So you're saying opposite. Now also, if you've got a shape like delta, like this, a diagonal doesn't even go inside the shape. Okay, so no, that would be the opposite.
Okay.
It's like UFO.
This one, Star Trek. It's the Star Trek badge. So which one's which? The diagonal that we've got to work out is which letter? C.
Oh, yes, see, it's the biggest one.
Exactly, yeah. And then this one can be B, this one can be A, doesn't matter if you did. We'll write that out. A squared plus, I'm actually going to take a little risk here, and I'm not going to draw the squares. I'm going to consider that you know what the squares are, because I've written A squared. I'm going to say, well, that's 45 squared plus 34 squared equals C squared. I think so, yeah. Well, definitely then. I think I did, but I might have done a busy day. I'll have a look if I didn't. This one will go up. I'm pretty sure we did because you guys were away. So I've not drawn the squares in this case. So this is how your work might eventually go if you're not drawing the squares. Can you see though, when it's 45 squared, people then just go, oh, it's 45 plus 34. So it's a mistake that can easily happen, especially in the heat of an exam. So we have to remember to do 45 squared. So having the square drawn reminds me. So 45 squared for me is 2025. Then 4 squared is 1156. If I add those together, I get 3,181 is c squared, but I've got to finish that with the square root of 3,801 is c, which is 56.4005 so on, but I want it correct to the nearest centimetre. So all of these numbers are to nearest centimetres. So I've got to finish it off by writing my answer is 56 centimetre to. Okay. Right.
Wait, could I just, sorry, it's just the last one.
What you did was identify the right angle triangle. So this is the side we're trying to find. So which I saw Eden went right, but it doesn't make any difference. I could go left, but we just identify a triangle. So the most important one is the longest. So this one, because it is opposite the right angle, so that one is C. So that's the 7 squared. Good question. We are told that this length from B is 8. And we're only going with half of it. Yeah? It's a good question. I was going to mention it, but it was understood. Questions? Feel about that question? You'll get the right answer?
Yeah.
Yeah? Alistair, I heard you realising some of you mistakes you made. What was it? Okay. How can you make sure that that isn't a thing in what if you look at your solution? Is there something that you think, that's a shortcut I took that I shouldn't have done, or just slight lapse? You've got everything covered, you've written everything down, you just because the facts, it's nothing we can improve. Rightio. Yeah. Trigonometry is next lesson. SOHCAHTOA. Pythagoras' theorem does not involve angles of any kind. So this right angle triangle has one angle with this right angle, but the other two angles, don't know what they are, and we're not interested in them. It doesn't involve, you don't need angles to work out. However, if we didn't have enough information about sides, we can use the angles to work out. That's trigonometry, that's what the general is. But just to finish us off, so your final homework question for Pythagoras' theorem, this one. So, challenge. I've got to say for this. Where is the right angle triangle? Easy.
And
So you are being asked to work out this length here. Right, that's what you did ask to work out. You need a right angled triangle that's going to help. Now, before we go anywhere, can anyone tell me where that is going to be? B2, B to D. If I did that, I have a right angled triangle, but does it help me? It doesn't help me. It introduces a length I could work out, but that's not the orange. Anywhere else? C to A. I've got one length there. I need the orange, but now I've got no, the red line would not be known. And the triangle on top is not. Final go. B to D, we just did that one. It's actually from D straight down. And for this question, you're going to have to actually work it out in two stages. You've got a rectangle, work that out, and you've got a triangle, work that out. Do we know this length? So that gives you the right angle triangle, and then this one we just use the length. So that is your homework. Start next lesson with it. Okay.